Okay. All right. Now, as I said last time, there's a generalization of the elasticity of substitution that you can use when you have more than two factors of production. And that's called the partial elasticity of substitution. And the partial elasticity of substitution, people call it sigma ij, is derived from the cost function. Looks like that. That's the partial elasticity of substitution. Now, for the two-factor case, the cross one between L and K will be the same as this sigma I just put on the board. Did anybody prove that for themselves? Anybody go about proving that? No? Well, you're lost. I told you to. I asked you to do that. So what I'll do is, instead of proving that, I'll show you that it'll show up where that sigma showed up. So let's think about, well, how would I generalize this to the multi-factor case? Okay. So the generalization of this to the multi-factor case is just look at it this way. Cy equals P, right? That is the derivative of cost with respect to output. That's marginal cost. That has to be equal to P, right? Y equals demand of P. Okay. All right. And my third equation is xi equals C sub I of W1 up to Wn and Y, right? This is also of all those same arguments, right? That is, those are the equilibrium conditions, and of course, still we'd have to have Y equals F of x1 up to xn. So if I had n inputs, those would be the corresponding equations. Everybody agrees with that? All right? Those would be the corresponding equations.